This is section 11.2. We're talking about the Pythagorean theorem. Many of you have probably talked about the Pythagorean theorem in the past, but the premise is that the two short sides of the triangle, so long as the triangle is a right triangle signified by a box in the corner, when they're squared and added together, are equal to the square of the longest side of the triangle. The longest side of the triangle is called the hypotenuse, and the shorter two sides of the triangle are both called legs. So, as we look at our triangle, we can find out the third side of a triangle if we know it's a right triangle. So we use the Pythagorean theorem, a squared plus b squared equals c squared, to do this. So in this case, we're given the two shorter sides. We square them both and add them together, giving us 25 plus 144 equals c squared. So c squared equals 169, and we take the square root of both sides, and we get c equals 13. So the longest side, the hypotenuse, is 13. In our second one, we have decimals, and so we have to consider what we do when we have decimals. We're going to approach the problem from the same way we did before, except now, instead of being able to do it in our head, we're going to have to think how we're going to take care of this with decimals. We're still going to start with a squared plus b squared equals c squared, but now we have 7.4 squared plus 3.2 squared equals c squared. So we're going to square 7.4. That gives us 54.76. Then we're going to square 3.2. That gives us 10.24. When we add these two together, we get 65. When we take the square root of 65, that equals 8.062. Rounding to the nearest tenth, that would be 8.1. Let's look at the bottom and look at two other types of problems. On number 3, we're given A, but not B, and we're given C. So we have 15 squared plus B squared equals 17 squared. That's 225 plus B squared equals 17 squared, which is 289. We now subtract 225 from both sides. That leaves us with b squared equals 64. And taking the square root, b equals 8. Our last example on this page, we're given b and c, but we're not given a. So when we put things in, we have 24 squared equals 25 squared plus a squared. Well, that means a squared plus 576 equals 625. When we subtract 576 from both sides, we're left with a squared equals 625 minus 576. That's 49. And the square root of 49 is 7. So the Pythagorean theorem is greatly useful to determine if something is a right triangle and how to find the missing side.